This problem is going to deal with how to solve work problems. An example of a work problem we see here is a senior roofer can complete a roof in 2 hours. His apprentice can finish it in 3 hours. Working together, how fast will the roof be completed? Now this question would be easy if they both did it at the same rate. If they both can complete the same job in 3 hours, working together, they'll take exactly half the time, or hour and a half. But since they have different rates to complete the job, the same job, we had to set up the problem a little bit differently. So when you're dealing with work problems with varying rates between one or more people working together, there's a certain way you have to set it up. So let's say you have two people working together. Person A and person B, and these can easily be machines if they're working together. First thing we want to do is find out their rate of work for the task. So it's going to be one task over their rate of work. I'll call that R sub A, the rate of work for person A. And rate of work for person B is going to be R sub B. I'm going to deal with the time that each person is going to put in to complete the job. Now they're working together, so they may be working the same amount of time together. Thus that the faster person is going to end up doing more work in that same amount of time. Now the second column here is going to deal with the part of the task that each person completed. That's going to be equal to the rate times the time. So it's going to be the T over R sub A and T over R sub B. Now the person with the faster rate is going to end up doing more of the work. But their part of the work, T over RA, plus the other person's part of the work, is going to equal the whole task, or 1. So that's how you set it up. So the amount of time that they're going to be working together over their rate, plus the time over the rate of the second person, is going to equal 1 whole task completed. All right, so let's check that out in a real problem. So we saw this before. It says senior roofer can complete the roof in 2 hours. His apprentice can finish it in 3 hours. Working together, how fast will the roof be completed? So if we look at the rate for, let's say person A, the senior roofer, is 2 hours, so 1 over 2. For B, it's going to be, it completes the job in 3 hours, so 1 over 3. And they both can be working for T amount of time. So the part of the task completed by the senior roofer is T over 2. And the amount of work completed by the apprentice is T over 3. Now if you add those together, that's going to be equal to 1 complete job. So equal to 1. Now we see we're adding 2 fractions here. Remember, when we add fractions, we need a common denominator. Common denominator between 2 and 3 can be 6. And make it equivalent here. To get from 2 to 3, I multiply by, to get from 2 to 6, I multiply by 3. So I need to multiply the top by 3. So it's going to be 3t. Go from 3 to 6 is multiplied by 2. So I'm going to multiply the top by 2. Okay, let me move it up here. So we have common denominators now. So we just add the numerators together. 3t plus 2t equals 5t over 6 equals 1. I want to get t by itself, so I can multiply both sides by 6. That gives me 5t equal to 6. To get t by itself, I divide both sides by 5. So I get t equals 6/5, or 1 1/5. 1/5 of an hour is 12 minutes, so I have 1 hour and 12 minutes. So it takes 1 hour and 12 minutes for these two roofers to work together to complete one roof. By themselves, they take a longer amount of time, and they are different rates, so we can't just divide the amount of time by 2. So we have to set up our rate of work times the amount of time they'll be working. That's going to be equal to their part of the task that that person completes. Those parts added together are going to equal one complete task. So we solve for t in this case to find out how much time working together it takes.